In section 4.5, we're going to learn about something called logarithmic functions. And these, the way that they show up most often in everyday life is in the forms of scales, like a way of measuring things. And we're going to talk about the Richter scale in this video, and then in a later video we're going to talk about how decibels work. The Richter scale is a way that scientists use to express the intensity of an earthquake. So you've probably seen the Richter scale before when it comes to earthquakes. And we're going to learn how the Richter scale works. And here's the basic idea. An increase of 1 on the Richter scale indicates that an earthquake is 10 times as powerful. So that means if you're comparing 3 earthquakes like this one, so I have an earthquake that was 5.5 on the Richter scale, 6.5, and then 7.5 on the Richter scale. The increase of 1 from 5.5 to 6.5 indicates that this earthquake is actually 10 times as powerful as this one. So even a small increase in the Richter number indicates a much more powerful earthquake. And if you go up another one, from 6.5 to 7.5, we get 10 times as powerful again. So if you were going to compare your earthquake that was 5.5 on the Richter scale to one that's 7.5 on the Richter scale, you would multiply by 10 2 times. And that's a difference of 100 times as powerful between 5.5 and 7.5 on the Richter scale. And the Richter scale is an example of something called a logarithmic scale. I already mentioned this a few seconds ago, but it's good to see it written out. And what I want to do next is to look at a couple fairly recently historical earthquakes, and we can compare how powerful they are. In 1989, there was a powerful earthquake that struck San Francisco. It was a magnitude 7.1 on the Richter scale. In 2011, this is more recent, there was a 9.0 magnitude quake that struck off the coast of Japan, and this caused a tsunami, actually. And what I want to do is compare these two earthquakes. So the one that struck San Francisco and this other one that's struck off the coast of Japan. So let's first look at the difference on the Richter scale. So just subtract the two numbers, 9.0 minus 7.1, and on the Richter scale, this is a difference of 1.9. But what does that mean in terms of the actual power of the two earthquakes? In order to figure that out, what we have to do is see what happens when we put 1.9 in the exponent of 10. So we have 10 1.9 times. This is similar to the way our exponential function worked in the last few sections. So when we do this, we can see that the Japanese quake was 10 to the 1.9 power, or 79.43 times as powerful as the San Francisco quake. So this difference of 1.9 on the Richter scale actually indicates a much, much, much more powerful earthquake. And to wrap up and make sure we understand how the Richter scale works, let's do another little example. What would the Richter scale measurement be for an earthquake that's 1,000 times as powerful as the San Francisco quake? Well, let's consider 1,000 is 10 to the third power. That's 10 3 times. So that means we would need to go up on the Richter scale by 3. So we can take our earthquake from San Francisco, which we know was 7.1 on the Richter scale, and we add 3 to that measurement to get a 10.1 magnitude earthquake. For a little bit of context for these numbers, the most powerful earthquake that has been measured using the Richter scale was a 9.5. So this hypothetical earthquake of magnitude 10.1 is much more powerful than the most powerful earthquake that we've ever detected on Earth.